For part two, we have to take the volume of each of these figures in cubic units. And for some of them, we will use the regular equation of volume equals area of the base times the height. But for those that come to an apex, it'll be 1/3 times the base times height. And this is the ones that come to an apex or the point. So like this on B is an apex. And that just means that as we take these cross sections, they get smaller and smaller and eventually go to a point where on this rectangular prism, as we take the cross sections, they stay as that rectangle. They stay consistent. So this first one, the area of the base, if we take the base as 4 times 5, that's going to equal 20. And so the volume is going to equal 20 times the height of 2, which equals 40 cubic units. The next one, a right rectangular pyramid. So the base is going to be 4 times 8, but the volume, since it goes to that apex, will be 1/3. Hold on. I made a mess up. 4 times 2, which equals 8. So the volume will be 1/3 times 8 times 5, which equals 40 divided by 3. I'm just going to keep it as that, as 40/3, because it doesn't divide nicely. It is about 13.3, repeating. The right cone, that also comes to an apex, and it already says that the base is equal to 15. Times that by the height, and times it by 1/3. That's going to equal 40 units as well. The triangular pyramid, the base is a triangle. So it's going to be 1/2, and since 4 and 5 are both of the legs of the triangle, it's not the hypotenuse. If we had the hypotenuse, we'd have to figure out what these legs are. 4 times 5 times 1/2, that equals 20 divided by 2, which equals 10. So the volume is going to be equal to 1/3 times 10 times the height, which is at a right angle of 12, and that is going to equal 60 units cubed. Oh, wait, hold on. 40 units cubed. Made a mess up there. Okay, the right cylinder, we have the radius and the base being a circle. That's going to equal pi times the radius squared, which equals 4 pi. And since the volume equals, it's not an apex, so we're going to do 4 pi, which is the base, times the height of 10 divided by pi. That equals 40 units cubed. And this last one, if we have a base of 30, we already know that the base area is 30, volume is going to be 30 times 4, which equals 120 units cubed. A right pyramid has a square base with side lengths of 10 units, each segment connecting the apex to a midpoint of the side. So that's an important statement. Each segment connecting the apex to a midpoint of the side of the base has length 30 units. So I'm going to draw it on this pyramid that's below, but basically that's saying that from the apex to the midpoint on the side length, that's 13. So each of these is 13, which if I draw this in red, that means that this right here is a right triangle that we can use to find the height. So if I redraw that right triangle, since I know that these side lengths are 10, I know that half of that is going to be 5, and we're finding the height. So using Pythagorean theorem, I know that 5 squared plus the height squared is going to equal 13 squared. This is a Pythagorean triple, so that's the height squared equals, this is going to be 144, and so the height square root is going to equal 12. So by using Pythagorean theorem, that looks messy. Try that again. Maybe I'll just say a squared plus b squared equals c squared. With the slant height, and half side length. H is equal to 12 units. Now to find the volume, this comes to an apex. So the volume is going to be 1/3 times the base area times the height. We know the base area, that's going to be 10 times 10. And the height's going to be 12. So volume is going to be 1/3 times 100 times 12, which equals 400 units cubed. A scale model of an oil tanker truck can hold 1 gallon of oil. If the trucking company wants a full-size truck to hold 80,000 gallons of oil, what must they apply for the scale factor? So these are volumes, because gallons is already a cubic measurement. So to find the scale factor, I know that k cubed equals 80,000 divided by 1. So k cubed equals 80,000, which take the square root of both not the square root, the cubed root. That should result in, calculating it, k equals 43.1. And we don't need a measurement because it's a scale factor. If instead the trucking company wants to make a truck that's 50 times, so this is k, the scale model of the truck that can hold 1 gallon, how many gallons will a new truck hold? So this is the dilated volume equals 550 cubed times 1, since that's the original. That's going to be 125,000 gallons. A prism has a volume of 50 cubic meters. Find a set of dimensions that will create this prism. So this is very much like a question that was in the beginning. So we could use like 5 meters by 5 meters by 2 meters, because 5 times 5 times 2 equals 50. Or you could come up with another one, 10 meters by 5 meters by 1 meter. So that's 5, or 10 times 5 times 1. Whatever one you choose to use, I'm going to choose to do this top one. Using the prism above in question 13, find the new set of the dimensions if the prism was dilated by a scale factor of 3. So you're just going to multiply each of these by 3. So 5 meters times 3, 5 meters times 3, and 2 meters times 3. Since it's just a length, it doesn't need to be squared or cubed or anything. So 15 meters by 15 meters by 6 meters. And there you go. Hopefully that helps with reviewing for the test.